GPS feels like magic. You pull a small rectangle out of your pocket, and it tells you where you are. Not roughly, not somewhere in this city. It tells you where you are on a planet that's spinning, wobbling, orbiting the sun while the sun orbits the galaxy. And it does it in seconds. So how does GPS actually work? Here's the honest answer. GPS is not really a position system. It's a time system. A system of clocks floating in space screaming the current time at the ground. And your phone is basically trying to solve a puzzle using that time before you get impatient and start tapping the screen like that helps. Let's start above the Earth. High overhead, dozens of satellites circle the planet in carefully planned orbits. Each one is a tiny, ultra-precise lighthouse. Not shining light, but broadcasting radio signals outward in every direction. Radio waves travel at the speed of light, which means if a satellite sends a signal right now, the signal will arrive a tiny moment later, depending on how far away you are. And that's the core idea. If you know exactly when a satellite sent a signal and you know exactly when you received it, then you know how long it traveled. And if you know how long it traveled, you know the distance. Distance equals travel time times the speed of light. No map required, no magical intuition, just a stopwatch and physics. So imagine you're standing on a rooftop holding a GPS receiver. A satellite sends a signal. Your receiver catches it. That gives you one distance. But that doesn't tell you where you are. Because being somewhere on a sphere is not exactly helpful. If you're 5,000 kilometers from a satellite, you could be anywhere on a giant invisible bubble around it. So you listen to a second satellite. Now you have two distance bubbles. Where they overlap, you get a ring. Better. Still not a location. Then you listen to a third satellite. Now 3 distance bubbles overlap, and you get 2 possible points. One is usually out in space, nowhere near the Earth, so you can ignore it. The other is on the surface. So with 3 satellites, you can almost solve your position. Almost. Because there's a problem hiding in plain sight. A problem so annoying that it forces the whole GPS system to become even more absurdly precise. Time. For this to work, you need to know exactly when the satellite sent the signal. And by exactly, I mean to within a few billionths of a second. Because light travels about 30 centimeters in 1 nanosecond. That's the distance between you're on this sidewalk and you're in that building. Satellites can do this. Because GPS satellites carry atomic clocks. These are clocks that don't drift by seconds per day. They drift by like a second in millions of years, give or take, because reality loves ruining perfect numbers. But your phone? Your phone does not have an atomic clock. Your phone has whatever tiny cheap clock fits inside a consumer device that also has to play videos, handle calls, and survive being dropped into toilets. So your receiver clock is wrong. And if your clock is wrong, your calculated distances are wrong. That means even if you get signals from 3 satellites, you'll still be off. This is why GPS actually needs 4 satellites. The 4th satellite gives the receiver enough information to solve for 2 things at once: your position in space and the error in your clock. It's like solving a mystery where you don't just need to find where the suspect is, but also fix the broken stopwatch you used to time their escape. So GPS is constantly doing 2 jobs: figuring out where you are and correcting what time you think it is. And all of that happens silently, in the background, every time you ask for directions to a coffee shop. Now, let's talk about those satellite clocks for a moment. An atomic clock is basically a machine that uses the natural vibration of atoms as a perfectly stable rhythm. Atoms don't care about weekends. They don't get tired. They don't run faster when it's cold. They just vibrate the way physics forces them to. And satellites lock onto that vibration like a metronome, and then it broadcasts timing signals based on it. So every satellite is constantly sending out, "I am here in space, and right now, according to my atomic clock, this is the time." No text, no labels. Just pure timing information encoded into the radio signal. Your receiver listens to multiple satellites at once. It compares their signals, it measures how late each one arrives, and it solves the geometry. And that geometry becomes your position. But there's another layer of cruel reality. Even if satellites have perfect clocks, the signal still has to travel through space and then through Earth's atmosphere. And the atmosphere is not polite. The ionosphere, high above the Earth, is full of charged particles, and it slows radio signals slightly. Not by much, but GPS doesn't have the luxury of not by much. A tiny delay turns into meters of error. And the ionosphere changes constantly. Day and night, seasons, solar storms. The sun can literally mess with your location. Then there's the troposphere, the lower atmosphere where weather happens. Water vapor changes how signals travel. And then there's the most human problem of all, buildings. In a city, signals bounce. Your receiver might get the real signal from the satellite and also a reflected copy that bounced off a glass tower. The reflected one arrives later. So your receiver thinks the satellite is farther away than it really is, and your position drifts. This is why GPS is sometimes perfect in an open field and sometimes completely confused in a downtown city canyon. Not because GPS is broken, but because you're trying to measure nanoseconds in a world made of messy matter. So how does GPS stay so accurate most of the time? Because it isn't just satellites in your phone. There's also a network of ground stations across the planet. They constantly track the satellites. They measure their orbits, they check their clocks, and they send correction data back up. The satellites update their broadcasts, the system stays synchronized, and the invisible timing net around Earth stays stable. GPS is less like a gadget and more like a living infrastructure. A global machine made of space hardware, atomic physics, radio waves, and constant maintenance. All so you can find a restaurant without having to talk to another human. And that's the weird part. GPS isn't really about navigation. Navigation is just what humans notice. What GPS really does is let a tiny device on the ground compare itself to clocks in orbit and use the speed of light as a ruler. It turns time into distance, distance into geometry, geometry into location. And it does it while everything is moving. The satellites are moving, the Earth is rotating, you're moving, even the atmosphere is shifting above you. Yet somehow the system keeps working. So the next time your phone calmly tells you turn left, remember what's actually happening. Somewhere above you, a satellite with an atomic clock is broadcasting a pulse. That pulse crosses space. It bends through the atmosphere. It reaches your device. And your device, with its cheap little clock, listens to 4 different space clocks, solves a geometry problem, corrects time itself, and produces a location. All in under a second. Not magic. Just a planet-sized time machine. Quietly running above your head, every moment, whether you notice it or not.